Human history feels long to us. We talk about ancient civilizations as if they stretch deep into the past. Thousands of years feel vast when measured against a single human life. Generations pass. Cities rise and fall. Empires collapse. Languages disappear. Written records fade into fragments. From our point of view, this already feels like deep time, but Earth does not measure time the way we do. Earth is approximately 4.5 billion years old. Compared to that, all of recorded human history is almost nothing. Even the entire span of modern humans is only a thin scratch on the planet's surface. If Earth's history were compressed into a single calendar year, human civilization would appear only in the final moments of the last day. This difference in scale matters more than we usually realize. When we ask whether we are the first civilization on Earth, we often answer from instinct, not from geology. We assume that because we see no evidence of earlier civilizations, none existed. But that assumption quietly relies on something that may not be true. It assumes that Earth preserves its past clearly. In reality, Earth does not preserve history the way a library does. It does not keep careful records. It does not store events for later inspection. Instead, Earth constantly reshapes itself. It erases, overwrites, and recycles almost everything that happens on its surface. From a geological perspective, time is destructive. Continents drift across the planet. When they collide, mountains rise. When they separate, oceans form. Over tens of millions of years, even the tallest mountain ranges are worn down into flat plains. Rivers change course. Coastlines move. Ice sheets advance and retreat. Entire landscapes are rebuilt again and again. Nothing on the surface is permanent. Even the rocks beneath our feet are temporary. Ocean crust is constantly created and destroyed. It rarely survives longer than 200 million years before being dragged into the mantle and melted. Anything built on it disappears completely. This means that most of Earth's surface today is relatively young. Very little remains from the deep past. The further back you go, the thinner the record becomes. Earth's memory fades rapidly with time. This creates a serious problem when we think about ancient civilizations. Civilizations are surface phenomena. They exist on land. They depend on stable climates and ecosystems. They build structures, but those structures are fragile on geological timescales. From Earth's perspective, civilizations are brief events. Even if a civilization lasted tens of thousands of years, that would be almost nothing compared to the age of the planet. It would be a momentary rearrangement of matter, followed by decay, erosion, and recycling. This means that human intuition about evidence is misleading. We expect evidence to last because we experience short timescales. We build something and assume it will remain. But Earth does not operate on human timescales. It operates on cycles millions of years long. Over those cycles, almost everything disappears. This is why the Silurian hypothesis begins not with a claim, but with a question. Not, did a civilization exist before us? But, would Earth even remember if one did? That question becomes unavoidable once we respect the difference between human time and geological time. When we say ancient, we often mean thousands of years. When geology says ancient, it means hundreds of millions of years. These are not comparable scales. What feels permanent to us is temporary noise to the planet. This does not mean that Earth's history is unknowable. Far from it. Science has reconstructed enormous amounts of the past through careful study of rocks, fossils, and chemical signatures. But those reconstructions are statistical and incomplete. They reveal patterns, not detailed stories. We know when forests spread across continents. We know when oxygen accumulated in the atmosphere. We know when mass extinctions occurred. But we do not know every event. We do not know every species. We do not know every environmental change, and we certainly do not know everything that happened on the surface at all times. This is why certainty fades with depth. The deeper into time we look, the more we must rely on indirect evidence. The planet does not preserve photographs. It preserves signals that survive erosion, pressure, heat, and chemistry. Anything that does not survive those forces is lost. Civilizations, by their nature, are fragile. They depend on structures that decay quickly. Metals corrode, stone cracks, concrete crumbles. Organic materials vanish entirely. Even large-scale infrastructure eventually breaks down into sediment and is recycled. Given enough time, a civilization can vanish without leaving obvious traces. This idea is uncomfortable because it challenges a quiet assumption. We assume that intelligence must announce itself. Permanently, Earth suggests otherwise. Intelligence may arise, flourish, and disappear without leaving a clear signature in deep time. Not because it was insignificant, but because Earth is efficient at erasure. This does not mean a past civilization existed. It means that the lack of evidence is not as strong an argument as we think. The Silurian hypothesis exists in this narrow space. It does not say, they were here. It says, Earth may not be able to prove that they were not. And that distinction matters. Science is careful not to confuse absence of evidence with evidence of absence, especially when the system being studied is known to destroy information. Earth is such a system. By understanding the difference between human time and planetary time, we begin to see why this question is even reasonable to ask. Not because it is likely, but because it exposes the limits of our confidence. Once we accept that Earth forgets most of its past, the conversation changes. We stop asking why we have not found evidence. We start asking what kind of evidence could survive at all. That question leads directly to the next section. We often imagine Earth as a careful record keeper. We picture layers of rock stacked neatly on top of one another, each preserving a moment in time, like pages in a book. Like a history waiting patiently to be read. But this picture is comforting, not accurate. Earth does not archive its past. Earth actively destroys it. From the moment something happens on the planet's surface, forces begin working to erase it. Wind, rain, heat, cold, chemical reactions, biological activity, and gravity all break things down. What survives does so by chance, not by design. This is why preservation is rare. Most living organisms leave no fossils at all. When they die, their bodies decay, are consumed or dissolve back into the environment. Only under specific conditions does fossilization occur: rapid burial, low oxygen, the right chemistry. Even then, preservation is never guaranteed. And fossils are the best case scenario for preservation. Civilizations fare much worse. Civilizations exist on the surface, fully exposed to weather, erosion, and biological activity. Their structures are not buried quickly. They are not protected. They are dismantled piece by piece. Even the strongest human-made materials are temporary on geological timescales. Metal rusts and fragments. Stone cracks under freeze-thaw cycles. Concrete absorbs water and breaks apart. Plastics degrade into smaller and smaller particles, eventually becoming indistinguishable from natural carbon compounds. Given enough time, everything becomes sediment. Sediment is Earth's way of forgetting. Sediment is transported by water and wind. It is deposited in layers, compressed, altered by heat and pressure, and eventually transformed into new rock. Over time, that rock may be uplifted, eroded again, or subducted into the mantle. At no point is the original structure preserved. This means that surface history is fragile. The further back in time we go, the less of the surface remains. Most of the land we walk on today did not exist hundreds of millions of years ago. It has been rebuilt many times. Ocean floors are even more temporary. They're constantly recycled. Anything built on them is guaranteed to vanish completely. This matters because civilization, by definition, is a surface phenomenon. It does not live deep underground. It does not exist in stable geological layers. It exists in environments that Earth is best at erasing. So when we ask why we do not see evidence of ancient civilizations, we must first ask whether Earth is capable of preserving such evidence at all. The answer is uncomfortable. Probably not, at least not in a clear, direct way. This is where many misunderstandings arise. People imagine that an ancient civilization would leave behind cities, machines, monuments, or tools that we could discover easily, but this expectation is based on short timescales. Human ruins feel ancient because they are thousands of years old, but thousands of years is nothing to Earth. It is not enough time for complete erasure. Millions of years change the picture entirely. After a few million years, forests erase roads, rivers erase foundations, hills flatten structures. After tens of millions of years, erosion and tectonics destroy entire landscapes. After hundreds of millions of years, most surface evidence is gone completely. If humans vanished today, our cities would not last. In 10,000 years, they would be overgrown ruins. In 1 million years, they would be unrecognizable. In 100 million years, they would be gone. What might remain are indirect traces, a brief disturbance in climate, a spike in extinction rates, unusual distributions of certain elements. But even these signals would fade over time. Carbon cycles through the atmosphere, oceans and rocks. Isotope signatures are diluted. Chemical anomalies are mixed and redistributed. Over long periods, even dramatic events blend into Earth's background noise. This is why Earth's history looks smooth at large scales. Sharp details are erased. Only broad trends remain. This creates a dangerous illusion. Because we see no obvious evidence of ancient civilizations, we assume none existed. But Earth's ability to erase information means that this assumption may be stronger than the evidence supports. Again, this does not mean a past civilization existed. It means the absence of obvious evidence is not decisive. This is a subtle but important point. Science relies on evidence, but it also relies on understanding the limits of evidence. When a system is known to destroy information, certainty must be adjusted accordingly. Earth is such a system. This is why the Silurian hypothesis does not focus on ruins or artifacts. It focuses on signals that could survive deep time even if barely, chemical fingerprints, global disruptions, long-term anomalies. But even these are not guaranteed to last. Earth's processes are powerful and relentless. Over geological time, they overwhelm almost everything. This is why the hypothesis is framed carefully. It does not claim hidden cities beneath our feet. It does not claim secret machines in the fossil record. It does not claim forgotten empires. It claims something simpler and more defensible. That Earth's deep past is not a complete record. That certainty fades with time. That our confidence in being the first is based more on intuition than on geology. Earth remembers life. It forgets details, and civilizations are details. Once we understand how efficiently Earth erases surface history, the Silurian hypothesis stops sounding dramatic. It becomes a reasonable question about preservation, not a claim about history. The planet is old, its memory is poor, and intelligence, if it ever arose before, would have been fragile. This realization sets the foundation for everything that follows. If Earth erases civilizations, then the next question becomes unavoidable. What kind of evidence, if any, could survive? That is where the hypothesis moves next. Once we accept that Earth erases surface history, the question changes. We stop asking, why don't we see ruins? We start asking, what kind of evidence could survive at all? This is where the Silurian hypothesis becomes precise instead of speculative. A civilization does not need to leave buildings to leave traces. It only needs to alter the planar in a way that survives Earth's recycling processes. And those alterations fall into a very narrow category. Not physical objects, not structures, but planetary scale signals. The most promising candidates are chemical. When a civilization becomes technologically active, it changes how energy flows through the environment. It extracts resources, it burns fuels, it concentrates materials, it produces waste. All of this alters the chemistry of the planet. Human civilization is already doing this. We have changed the composition of the atmosphere. We have shifted carbon from underground storage into the air. We have altered nitrogen cycles through agriculture. We have introduced synthetic compounds that did not exist before. These changes leave measurable signals. In principle, a past civilization could do the same. This is why scientists interested in the Silurian hypothesis focus not on fossils of machines, but on chemical fingerprints. One example is carbon isotopes. Carbon exists in different forms called isotopes. Biological and industrial processes favour certain isotopes over others. When large amounts of fossil carbon are burned, the balance between these isotopes shifts in a measurable way. This shift is happening right now. In the far future, if Earth's records survive long enough, a scientist might see a brief period where carbon isotope ratios change rapidly. They might not know it was humans, but they would know something unusual happened. In theory, a past civilization could leave a similar signal. Another example is oxygen levels. Life itself transformed Earth by producing oxygen. This change is clearly visible in the geological record. It reshaped the planet completely. If a civilization altered atmospheric chemistry at a large scale, that change might leave a detectable signal. But here is the limitation. Earth's atmosphere is dynamic. Gases mix, reactions occur, oceans absorb carbon and release it again. Volcanic activity introduces new material. Over millions of years, atmospheric composition stabilizes. Short-term disturbances fade. This means that even major chemical changes can disappear if they are not sustained long enough. A civilization that lasted a few thousand or even tens of thousands of years would likely leave only a brief chemical anomaly. That anomaly would be smeared out, diluted, and eventually absorbed into Earth's long-term cycles. It would not stand out clearly. Another possible signal is unusual element distribution. Mining concentrates certain metals in unnatural ways. Industrial processes refine materials and redistribute them across the surface. In theory, this could leave behind patterns that do not match natural geological processes. But again, time works against preservation. Metals corrode, sediments redistribute elements, plate tectonics mix crustal material. Over long periods, unnatural concentrations are spread out and become indistinguishable from natural variation. Only extremely large and long-lasting industrial activity would leave a durable signal. This places strong limits on the hypothesis. If a past civilization existed, it likely did not resemble modern humanity at peak industrial scale. Or if it did, it existed for a very short time before collapsing. There is also the question of synthetic materials. Some compounds created by humans do not occur naturally. Certain plastics, chemicals, and long-lived radioactive isotopes could, in principle, survive for extended periods. But even here, Earth has an advantage. Plastics break down physically and chemically. Radiation decays. Sediments bury and transform materials. Over millions of years, even synthetic compounds are altered beyond recognition. Nothing on the surface is safe from time. This leads to an important conclusion. The kind of evidence that could survive deep time is not specific. It does not say civilization. It does not say technology. It says something unusual happened. And even that signal becomes weaker the further back you go. This is why scientists do not search the geological record expecting to find proof of ancient intelligence. They search to understand the limits of what could possibly be preserved. The Silurian hypothesis is built on restraint. It acknowledges that Earth shows no clear evidence of a past industrial civilization, and that fact matters. It places boundaries on speculation. But it also acknowledges that Earth's ability to erase information is strong enough that certain possibilities cannot be ruled out with absolute certainty. The hypothesis lives in this narrow gap, not in belief, not in denial, but in uncertainty shaped by physics and geology. This is why the question remains scientific, not because it is likely, but because it reveals how fragile planetary memory is. And once we understand what kind of evidence might survive, the next realization becomes unavoidable. Even those signals are temporary. At first, chemical evidence sounds promising. Unlike buildings or tools, chemical changes affect the planet itself. They spread across air, water, and rock. They feel more permanent, more durable, less fragile than cities or machines. But Earth has a way of dissolving even its own chemistry. To understand why, we have to think in cycles. Earth is not static. Every major element moves continuously Through different forms and locations, carbon moves between atmosphere, ocean, living organisms, sediments, and rock. Nitrogen cycles through soil, air, life, and water. Oxygen reacts, binds, and is released again. These cycles are slow, but they are relentless. Nothing stays in one place forever. This means that chemical signals do not sit still. They are diluted, redistributed, and eventually erased by mixing. A sharp spike in one era becomes a gentle curve in another. Given enough time, it blends into the background. This is one of the most important limitations of the Silurian hypothesis. Even if a civilization significantly altered the planet's chemistry, those changes would not necessarily survive hundreds of millions of years in a recognizable form. Consider carbon again. Human civilization is currently releasing carbon that was locked underground for millions of years. This creates a noticeable shift in carbon isotope ratios. Scientists can measure it clearly today, but over long periods, oceans absorb carbon. Plants incorporate it, rocks store it, volcanic activity releases new carbon. Subduction pulls old carbon into the mantle. After enough time, the signal weakens. In tens of millions of years it may still be detectable, but ambiguous. In hundreds of millions of years it may be indistinguishable from natural variation. The same applies to temperature. A civilization could cause global warming or cooling. That change might trigger extinctions or ecosystem shifts. These would appear in the geological record, but Earth has experienced many rapid climate changes without intelligence. Massive volcanic eruptions, asteroid impacts, shifts in ocean circulation. All of these can produce similar effects. From deep time, it becomes difficult to say why a change occurred. The record shows what happened, not who caused it. This creates a serious ambiguity. Even if a civilization left behind a clear disruption, scientists millions of years later might interpret it as a natural event. And in most cases, they would be right to do so. Earth has no label that says intelligence was here. Another issue is time resolution. Geological layers compress time. A layer that appears thin may represent tens of thousands or millions of years. Fine details are lost. Short-lived events are smeared out. This means that even dramatic changes can appear gradual in the record. A civilization that existed for a few thousand years might leave a signal so thin that it disappears entirely when averaged over geological timescales. This is not speculation. It is something geologists deal with constantly. Short events are hard to see. Long events dominate the record. Civilizations, unfortunately, are short. There is also the issue of biological overprinting. Life responds quickly to environmental changes. After a disturbance, ecosystems reorganize. New species emerge, old ones disappear. Over time, biological activity smooths out chemical anomalies. Life heals. The planet. Forests grow back. Oceans stabilize. Microorganisms regulate chemistry. Earth tends toward equilibrium. This means that even if a civilization caused damage, life itself would work to erase the traces. Ironically, the more life a planet has, the better it is at hiding disturbances. This makes Earth especially good at forgetting. So when scientists look deep into the past, they are not looking for obvious signs of intelligence. They are looking for patterns that do not fit. So far, none demand a technological explanation. There are mysteries, yes, sudden extinctions, rapid climate shifts, unusual recoveries. But all of these can be explained by known natural processes. That matters. The Silurian hypothesis remains cautious because science demands caution. It acknowledges that Earth shows no clear evidence of a past industrial civilization. This is not brushed aside. Instead, it is incorporated into the hypothesis itself. If a past civilization existed, it must have been short-lived, limited in scale, low impact, or extremely ancient. Anything large, global, and long-lasting would almost certainly leave a stronger signal. This significantly narrows the range of possibilities. The hypothesis does not open the door to grand lost empires. It closes most doors and leaves only a few narrow ones slightly open. That is why it remains scientific rather than speculative. It is not about believing something happened. It is about recognizing what Earth can and cannot preserve, and Earth is very good at preserving life and very bad at preserving events. Civilizations are events. They're bursts of organization. They consume energy, rearrange matter, and then disappear. From a planetary perspective, they are noise. This realization does not weaken science. It strengthens it. It forces us to admit that certainty has limits, that our confidence in being the first is based on the silence of the record, not on proof. Earth is quiet about its deepest past. That quiet does not mean nothing happened. It means the planet moved on. And once we accept that, the Silurian hypothesis becomes what it truly is. Not a claim about lost civilizations, but a lesson about time, memory, and humility. When people hear the idea that a civilization might have existed before humans, their first reaction is usually confident. We would know. We have fossils. We understand Earth's past. This confidence feels reasonable. After all, science has reconstructed millions of years of life from bones, shells, and chemical traces preserved in rock. We know about dinosaurs, ancient forests, early mammals, and even microscopic organisms that lived billions of years ago. So how could something as significant as a civilization escape detection? The answer lies in a misunderstanding of what the fossil record actually is. The fossil record is not a complete record of life on Earth. It is a fragmentary sample, shaped by chance, environment, and preservation. It tells us a great deal, but it also leaves enormous gaps. Most living things never become fossils. When organisms die, they usually decay, are eaten, or dissolve into their surroundings. For fossilization to occur, very specific conditions must be met: rapid burial, low oxygen, the right mineral environment. Even then, preservation is uncertain. This means the fossil record is heavily biased. It favors organisms with hard parts like shells and bones. It favors environments where sediment accumulates, especially shallow oceans. It disfavors forests, mountains, and dry land. It almost completely ignores soft-bodied life. Entire ecosystems can exist for millions of years and leave almost no trace. This is not a failure of science. It is a property of nature. Now consider intelligence. Intelligence itself does not fossilize. Thought leaves no imprint in rock. Social organization leaves no skeleton. Language does not preserve itself in sediment. Culture, beliefs, and knowledge vanish the moment living carriers disappear. What about tools? Tools can fossilize under certain conditions, but only if they are preserved quickly and buried deeply. Even then, stone tools last longer than metal ones. Wood tools vanish completely. Complex machines break down rapidly. This means that even if an intelligent species existed, its cognitive abilities would leave almost no direct fossil evidence. The fossil record tells us what lived, not how it thought. This is an important limitation. We often assume that intelligence must leave obvious evolutionary traces, but evolution does not preserve intelligence directly. It preserves bodies. And bodies can remain unchanged even as behavior changes dramatically. Human anatomy existed long before human civilization. For most of our species' history, we were anatomically modern but technologically simple. If humans had gone extinct before agriculture, our fossils would not clearly indicate advanced intelligence. This shows how misleading anatomy alone can be. Now scale this problem up. If a non-human intelligent species existed millions of years ago, its fossils might look completely ordinary. Just another animal species with no obvious sign of civilization. Even if that species used tools, built structures, or organized societies, those behaviors would not necessarily leave a fossil signature. Behavior disappears faster than bones. There is also the issue of time resolution. Fossil layers compress enormous spans of time. A thin layer of rock might represent thousands or even millions of years. Short-lived species can disappear entirely within that compression. This means that brief events are often invisible. A civilization that existed for 10,000 years would be a blink in geological time. Its rise and fall might be compressed into a layer too thin to detect. Even mass extinctions can appear sudden or gradual depending on how they are preserved. The fossil record smooths sharp edges. This creates a dangerous illusion of completeness. Because we see long stretches of consistent patterns, we assume nothing unusual occurred in between. But this assumption only holds if preservation was continuous and uniform, which it was not. Large gaps exist in the record. Some are known, others are invisible. This is why paleontologists speak carefully. They reconstruct patterns, not stories. They infer trends, not specific events. They work with probabilities, not certainty. When scientists say there is no evidence for a past civilization, they mean something precise. They mean there is no direct, unambiguous fossil evidence. They do not mean it was impossible. This distinction matters. The Silurian hypothesis exists because fossils are excellent at preserving life, but poor at preserving intelligence and culture. The record shows us what survived, not everything that occurred. This does not weaken science. It clarifies its limits. Science does not claim omniscience, it claims careful interpretation of incomplete data. And incomplete data must always be treated with humility. Earth's fossil record is remarkable, but it is not a perfect memory. It is a window, not a mirror. Once we accept this, the certainty surrounding first civilization begins to soften, not collapse, just soften. We move from absolute claims to probability, and in science that is progress, because now we can ask better questions, not why don't we see them, but what would we expect to see if intelligence existed? That question leads directly to the next realization. Even if intelligence existed, it might leave no recognizable fossil trace at all. That is where the hypothesis deepens. The fossil record gives us an extraordinary view into Earth's biological past. It tells us what kinds of bodies existed, how they changed over time, and how life responded to environmental shifts. But there is something it does not capture well at all: intelligence. Intelligence is not a physical object, it is a process. It exists in behavior, decision-making, social interaction, and knowledge transfer. None of these leave direct marks in rock. This is a critical limitation that is often overlooked. When we imagine intelligent life, we imagine technology, cities, and tools. But intelligence itself does not require these things. It does not require metal. It does not require buildings. It does not even require permanent structures. Intelligence can exist quietly. Human intelligence existed long before civilization. For hundreds of thousands of years, humans lived as hunter-gatherers. We made simple tools. We communicated. We passed knowledge across generations. But our physical footprint was minimal. If humans had gone extinct before agriculture, the fossil record would not clearly show that we were different from other animals in any dramatic way. Our skeletons would look like just another species of primate. This realization is uncomfortable. It means that intelligence, even advanced intelligence, can be nearly invisible in deep time. Now imagine an intelligent species that followed a different path than humans. Perhaps it relied more on biological solutions than mechanical ones. Perhaps it used tools made of organic materials like wood, fibre, or bone. Perhaps it lived in harmony with its environment rather than reshaping it aggressively. Such a civilization would leave almost no lasting physical trace. Even stone tools, which preserve relatively well, are rare and easy to miss. They must be found in the right context and recognized correctly. Many early human tools were overlooked for decades before being identified. Now extend this difficulty across tens or hundreds of millions of years. Layers shift, rocks deform, context is lost, artifacts are scattered or destroyed. Recognition becomes nearly impossible. This is why paleontology focuses on anatomy rather than behavior. Bones preserve, behavior does not. Social structures, languages, rituals, and technologies vanish without trace once living organisms are gone. Even writing disappears quickly unless preserved under exceptional conditions. Intelligence lives in minds. Minds do not fossilize. There is also an evolutionary complication. Intelligence does not require dramatic anatomical change. Large brains can evolve gradually. cognitive complexity can increase without obvious skeletal markers. Tool use does not always correlate with specific physical traits. This means that an intelligent species could exist without leaving an anatomical signal that clearly marks it as special. From a fossil perspective, it would look ordinary. This undermines a common assumption. We assume that intelligence must announce itself through evolution, that there must be a clear trail leading toward it. But evolution is not goal-oriented. It does not label outcomes. It simply preserves what works. Intelligence may arise when conditions allow, then disappear when conditions change. If that happens, evolution moves on. No marker remains to say, intelligence was here. This creates a blind spot. We are good at recognizing long-lasting trends. We are less good at recognizing short-lived peaks. And intelligence may be a peak rather than a stable state. Civilizations in particular are fragile. They depend on environmental stability. Climate, resources, and ecosystems must remain within narrow limits. When those limits are exceeded, civilizations collapse. Earth has experienced many dramatic environmental shifts. Ice ages, volcanic winters, ocean anoxia, rapid warming. Any of these could end a civilization quickly. From a geological perspective, such an event would simply look like another extinction or transition. The cause would be ambiguous, and even if intelligence played a role, that role would not be preserved. This is why the fossil record alone cannot rule out the possibility of past intelligence. It can tell us what bodies existed. It cannot tell us how those bodies organized themselves. It can show us life's diversity. It cannot show us culture. This does not mean intelligence was common. It means that fossils are not the right tool to detect it. This is an uncomfortable conclusion because we trust fossils. They feel solid. They feel objective. They feel like proof. But fossils are selective memories. They remember shells better than skin. They remember oceans better than land. They remember bodies better than minds. The Silurian hypothesis does not argue that fossils hide evidence of past civilizations. It argues that fossils were never designed to preserve such evidence in the first place. This is why certainty becomes difficult. We're trying to answer a question using a record that is not optimized to store the answer. This does not invalidate science. It clarifies its limits. Science excels when its tools match its questions. When they do not, humility is required. The Silurian hypothesis exists in that space of humility. It does not say there was a civilization. It says, our tools may not be sufficient to guarantee that there was not. That is a very different claim, and it is a scientifically honest one. Once we accept that intelligence does not fossilize and that behavior disappears quickly, the next question becomes unavoidable. If we cannot rely on fossils, and if chemistry fades, then what would a deep-time civilization even look like from our perspective? That question takes us beyond fossils and into the nature of civilization itself. When people imagine a past civilization, they usually imagine something familiar. Cities made of stone, roads cutting through landscapes, large structures that dominate the environment, machines, tools, and monuments that announce intelligence clearly and permanently. This picture feels natural because it is based on us. Human civilization is loud. It reshapes land, alters rivers, clears forests, and extracts enormous amounts of energy from the planet. Our technology is visible, our footprint is heavy, our presence is obvious. So when we think about ancient civilizations, we assume they must leave similar scars. But this assumption may be deeply flawed. Civilization is not a single thing. It is a strategy, a way of organizing energy, resources, and information. And there are many ways to do that. Human civilization followed a particular path because of specific conditions. We had access to fossil fuels. We developed metallurgy early. We relied on agriculture that required large-scale land use. We built permanent settlements that grew into cities. None of these choices were inevitable. They were responses to the environment we inherited. A civilization arising under different conditions could follow a completely different path, one that leaves far fewer traces. This is a key insight of the Silurian hypothesis. If a past civilization existed, it may not resemble us in any meaningful way. It may not have built cities. It may not have used metal extensively. It may not have altered landscapes dramatically. It could have been intelligent, organized, and technologically capable without being industrial in the modern sense. We often equate intelligence with industry because that is how our story unfolded. But intelligence does not require factories, highways, or global extraction. Consider early human societies. For most of our existence, humans lived with minimal environmental impact. Small populations, simple tools, local resource use, knowledge passed through culture rather than infrastructure. These societies were intelligent, adaptive, and complex, yet they left very little lasting physical evidence. Now imagine a civilization that never transitioned into large-scale industrialization. Perhaps it developed advanced knowledge of biology rather than machinery. Perhaps it relied on renewable energy exclusively. Perhaps it optimized efficiency instead of expansion. Such a civilization could exist for thousands or even tens of thousands of years without dramatically reshaping the planet. From Earth's perspective, it would be almost invisible. This challenges a core assumption. We assume that progress must look like growth, more energy use, more extraction, more infrastructure. But growth is only one possible expression of intelligence. Stability is another. A civilization focused on maintaining balance with its environment might intentionally avoid large-scale alteration. It might limit population size. It might build using biodegradable materials. It might favor temporary structures over permanent ones. Such choices would leave almost no trace in deep time. This is not speculation pulled from fiction. It is a logical extension of how intelligence can interact with an environment. Even today, we see alternative paths. Some societies prioritize sustainability. Others prioritize expansion. These are cultural choices, not biological necessities. A non-human civilization could make very different choices. There is also the question of timescale. Human civilization feels ancient because we measure it in generations. But from a geological perspective, even the entire history of agriculture is almost nothing. A civilization that existed for 10,000 years and then disappeared would barely register in the rock record. And disappearance does not require catastrophe. Civilizations collapse for many reasons: climate shifts, resource depletion, internal instability, disease, slow decline. Not all collapses are violent or sudden. A civilization could fade quietly, knowledge lost, population dwindles, structures decay, life moves on. From Earth's perspective, this looks no different from any other ecological transition. This brings us to another uncomfortable idea. We assume that intelligence must dominate its environment to be visible. But dominance is not required for intelligence to exist. Many intelligent systems in nature do not dominate. They adapt. Octopuses are intelligent but leave no trace. Crows are intelligent but leave no record. Dolphins are intelligent but leave no fossil signature of culture. Intelligence can exist without reshaping the planet. Human intelligence happened to coincide with industrial technology. That combination created a visible planetary footprint. But that is not the only possible outcome. This realization narrows the Silurian hypothesis in an important way. It does not suggest a past civilization like ours with global infrastructure and heavy industry that somehow vanished completely. That would be unlikely to erase entirely. Instead, it opens the possibility of different kinds of civilizations. Civilizations that were smaller in scale, shorter in duration, less extractive, more biologically integrated. Such civilizations would leave few long-term signals. This does not make them inferior, it makes them harder to detect. The problem is not that Earth hides obvious evidence. The problem is that we are looking for the wrong kind of evidence. We are looking for ourselves in the past, but the past may not contain anything that looks like us. The Silurian hypothesis challenges this bias. It forces us to separate the concept of intelligence from the specific form human civilization took. Once we do that, the range of possibilities expands, even as the probability of detection shrinks. This does not make the hypothesis stronger in terms of evidence, it makes it more realistic, because Earth does not preserve nuance. And intelligence, when quiet, is all nuance. This leads directly to the next section. If civilizations can take many forms, then the most plausible ones to vanish completely are those that minimize their impact. Understanding those forms helps us understand what might be missing from Earth's record. Once we move past the idea that all civilizations must look like ours, a quieter possibility emerges. Intelligence does not need to reshape a planet to exist. In fact, the more carefully a civilization manages its environment, the less visible it becomes in deep time. From Earth's perspective, restraint leaves fewer scars than ambition. This creates a paradox. The civilizations most likely to survive for long periods may also be the hardest to detect after they are gone. Human civilization is unusual in how rapidly and dramatically it altered Earth. We burned vast amounts of stored carbon, we cleared forests, we rerouted rivers, we mined deeply and widely. These actions left strong signals, but none of these actions were required for intelligence itself. They were the result of choices made under specific circumstances. A civilization that prioritized balance over expansion would behave very differently. It might limit population growth. It might avoid large-scale extraction. It might rely on renewable energy sources that do not accumulate long-term waste. Such a civilization could exist for thousands or tens of thousands of years without leaving a strong geological signature. Even its collapse might leave little trace. Civilizations do not need to end in fire or catastrophe. They can fade. Knowledge can be lost gradually. Skills can disappear as populations shrink. Technology can regress without dramatic destruction. Structures decay naturally. Materials return to the environment. From a geological perspective, this looks like nothing at all. The land returns to forest. Rivers resume natural paths. Ecosystems recover. Earth absorbs the change. This process happens constantly on smaller scales. Abandoned human settlements disappear within centuries. Forests reclaim farmland. Animals return. Only subtle hints remain. Extend that process across millions of years, and even subtle hints vanish. This is why Earth's deep past appears smooth. Disruptions are smoothed out. Peaks and valleys blend together. Only the largest, longest-lasting changes stand out. A civilization that avoided large disruptions would leave almost no trace. There is also the question of materials. Human civilization relied heavily on materials that degrade quickly. Steel rusts, concrete cracks, plastics fragment and disperse, wood rots, even glass erodes over time. If a civilization relied on biodegradable materials or biological structures, its physical footprint would be even smaller. Organic materials rarely fossilize unless preserved under exceptional conditions. Most biological structures disappear completely. A civilization built primarily from living systems would leave no artifacts at all. This idea may sound abstract, but biology already demonstrates its feasibility. Beavers reshape landscapes dramatically using organic materials. Over time, their dams decay and rivers adjust. After enough time, little evidence remains. Termites build massive structures that alter soil chemistry and airflow. Over long periods, those structures disappear. Life can engineer environments without leaving permanent marks. An intelligent species could do the same, but with more intention. Such a civilization might focus on knowledge rather than infrastructure, culture rather than construction, adaptation rather than control. From Earth's perspective, this would be almost invisible. Even if such a civilization achieved advanced understanding of nature, it might not produce anything recognizable as technology in the fossil record. This challenges another assumption. We assume that intelligence naturally leads to permanent artifacts, but permanence is a human preference, not a requirement of intelligence. A civilization might value impermanence. It might design everything to return to the environment. It might avoid leaving waste. It might see long-term planetary stability as more important than leaving monuments. Such values would erase the civilization's trace even faster. There is also the issue of scale. We often imagine civilizations as global, but intelligence does not require global dominance. A civilization could exist in limited regions, occupying specific ecological niches. If it remained geographically restricted, its impact would be diluted further. Local disturbances would be absorbed by surrounding systems. From deep time, those disturbances would be indistinguishable from natural variation. This is why scale matters so much in the Silurian hypothesis. Only civilizations that operate at planetary scale for long durations are likely to leave lasting evidence. Anything smaller or shorter-lived is quickly erased. This severely limits what could be detected, and it leads to a sobering realization. The more intelligent and careful a civilization is, the less likely it is to announce itself across deep time. Earth does not reward intelligence with permanence, it rewards persistence with balance. This perspective shifts the question again. The problem is not that Earth hides evidence of past civilizations. The problem is that civilizations capable of lasting may be designed to disappear cleanly. This does not mean such civilizations existed. It means that if they did, Earth would not advertise them. The Silurian hypothesis remains cautious here. It does not argue that Earth once hosted a sophisticated, hidden civilization. It argues that our methods of detection are tuned to loud, destructive civilizations like our own. Quiet civilizations fall through the cracks. This realization also reflects back on us. If we want our civilization to persist, the behaviors that maximize survival may be the same behaviors that minimize long-term geological visibility. The planet does not care about legacy, it cares about equilibrium. Understanding this helps explain why the Silurian hypothesis is less about the past than about the future. It forces us to ask what kind of civilization can exist without destabilizing the system that supports it. And once we ask that question, we are no longer just studying ancient history, we are studying ourselves. Once we accept that civilizations can vanish quietly, another question naturally follows. Does Earth's history contain any moments that feel unusual enough to raise questions? Not proof, not evidence of intelligence, but moments that seem difficult to explain at first glance. This question must be handled carefully. Earth is a violent and dynamic planet. Strange events are common. Catastrophes happen, climate shifts rapidly, life collapses and recovers. Most of these events have strong natural explanations, but some moments in the geological record still stand out. Scientists notice them not because they demand extraordinary causes, but because they are abrupt, global, and impactful. One example is sudden climate change. Earth's climate has shifted many times, but some transitions appear unusually fast. Temperatures rise or fall sharply. Ice sheets advance or retreat quickly. Ecosystems struggle to adapt. From a human perspective, these changes feel dramatic. From a geological perspective, they are still rare enough to draw attention. Another example is mass extinction. Earth has experienced at least 5 major mass extinctions. In each case, a large percentage of life vanished in a relatively short time. Entire ecosystems collapsed. Dominant species disappeared. The planet reorganized itself. These events are deeply studied because they reshape evolution, but none of them require intelligence to explain. Asteroid impacts, massive volcanic eruptions, ocean circulation collapse, rapid greenhouse warming. Nature has many ways to disrupt itself. Still, some extinction events show patterns that invite careful study, not because they suggest intent, but because their causes involve complex interactions between atmosphere, oceans, and life. Then there are chemical anomalies. In some geological layers, scientists find unusual ratios of isotopes. Carbon shifts abruptly. Oxygen levels change. Sulfur behaves strangely. These signals indicate large disruptions in Earth's chemical cycles. Again, these events are usually explainable through known processes. Volcanism releases carbon. Microbial blooms alter oxygen. Ocean stagnation changes chemistry. But the important point is this: the geological record is capable of recording planetary-scale disturbances, even if it cannot preserve fine details. So if a civilization ever altered the planet dramatically, it would most likely appear as a disturbance rather than a structure. This is why the Silurian hypothesis focuses on global signals rather than artifacts. The question becomes, do any of Earth's past disturbances look unnatural? So far, the answer is no. Every major event studied to date has plausible natural explanations. In most cases, multiple explanations exist, and scientists work to narrow them down through evidence. This is critical. The hypothesis does not claim unexplained events exist. It asks whether explained events could ever be misinterpreted, because explanation depends on context. If a civilization caused environmental damage millions of years ago, scientists today might still explain it naturally, because natural explanations exist and are sufficient. This does not mean the explanation is wrong. It means alternative explanations may not be distinguishable. That is a subtle but important distinction. For example, consider rapid carbon release. We know volcanic eruptions can release enormous amounts of carbon. We also know biological feedbacks can amplify warming. These processes can mimic industrial effects. From deep time, it may be impossible to tell whether carbon entered the atmosphere from volcanism or combustion. Both leave similar chemical signatures. This does not imply intelligence was involved. It implies ambiguity exists. Earth's record tells us what happened, not why it happened. Another example is rapid ocean acidification. This can occur through natural CO2 release. It can also occur through biological imbalance. Either way, the chemical outcome is similar. The fossil record captures consequences, not intentions. This is why scientists are careful not to overinterpret anomalies. The Silurian hypothesis remains grounded precisely because it does not claim anomalies as evidence. It claims that anomalies are not definitive. There is a difference. Science thrives on caution. If there were a past civilization, its footprint would likely resemble a natural catastrophe rather than a technological signature. And natural catastrophes are common enough that such a footprint would not stand out clearly. This is where confidence weakens, not because evidence points to intelligence, but because evidence cannot rule it out completely. The record is noisy. Earth's history is filled with dramatic changes. Most of them are natural. A hypothetical civilization would have to compete with these signals, not rise above them. This makes detection extremely difficult, and that difficulty increases with time. Older, events are more compressed. Signals blur, causes overlap, certainty fades. So when scientists say there is no evidence of a past civilization, they are being accurate, but they are also acknowledging a limitation. The absence of a clear technological signal does not prove impossibility. It proves that Earth's record is dominated by natural processes. This is exactly what we should expect. Nature does not preserve labels, it preserves outcomes. The Silurian hypothesis asks us to look at Earth's history with this perspective, not to find hidden stories, but to understand how easily stories disappear, and once we accept that, the next realization follows. Even the strangest events in Earth's past do not require intelligence to explain, which means that natural explanations will always dominate. When scientists study Earth's past, they follow a strict rule. Always prefer the simplest explanation that fits the evidence. This is not conservatism, it is discipline. Earth is a planet shaped by powerful natural forces. Volcanism, tectonics, climate feedbacks, biological evolution, and asteroid impacts are not rare exceptions. They are normal features of planetary history. Because of this, almost any large-scale change in Earth's past can be explained without invoking intelligence. This matters deeply for the Silurian hypothesis. Even if a past civilization altered the planet, its effects would almost certainly be interpreted as natural. Not because scientists are biased, but because natural explanations are abundant, well-supported and sufficient. Consider volcanism. Large volcanic provinces can release massive amounts of carbon dioxide over relatively short geological times. This can cause rapid global warming, ocean acidification, and widespread extinctions. These events leave strong chemical and biological signals. From the geological record alone, volcanic carbon release and industrial carbon release can look remarkably similar. Both shift carbon, isotopes, both warm the planet, both disrupt ecosystems. Without additional context, the causes are indistinguishable. Now consider asteroid impacts. An impact can trigger sudden climate collapse, wildfires, atmospheric dust, acid rain, and long-term ecological disruption. These effects can last thousands to millions of years. If a civilization somehow caused a global catastrophe, the resulting geological record might look exactly like an impact event. Nature already produces devastation on a planetary scale. This creates a fundamental problem for detection. Any civilization capable of altering Earth significantly would leave effects that fit comfortably within known natural categories. There would be no clear marker saying this was done by intelligence. The geological record is outcome-based, not cause-based. It tells us what happened. It rarely tells us why. This is why skepticism dominates scientific thinking about the Silurian hypothesis. Scientists do not dismiss the idea because it is absurd. They dismiss it because there is no unique signature of intelligence in deep time. If every possible signal can be explained naturally, then intelligence is unnecessary as an explanation, and science avoids unnecessary explanations. This is not a flaw. It is how reliability is maintained. The hypothesis survives only because it does not demand reinterpretation of known events. It does not say, this extinction was caused by a civilization. It says, if a civilization caused an extinction, we might never know. That is a very different position. The burden of proof remains extremely high, and rightly so. Extraordinary claims require extraordinary evidence. The Silurian hypothesis makes no extraordinary claims. It points out extraordinary uncertainty. It reminds us that Earth's history is noisy. Signals overlap. Processes interact. Causes blur. Over time, sharp events become smooth trends. This makes Earth's past difficult to read with precision. This difficulty grows rapidly as we move deeper into time. Recent events are clearer. Ancient events are murky. Deep time events are shadows. This is why confidence declines with age. A disturbance 10,000 years ago might leave recognizable evidence. A disturbance 10 million years ago is harder to identify. A disturbance 200 million years ago may be invisible. This gradient of certainty matters. It means that claims about deep history must always be softer than claims about recent history. Science understands this, which is why the Silurian hypothesis remains cautious and restrained. It does not say that natural explanations are wrong. It says that natural explanations dominate by necessity. If intelligence ever existed before us, it did not announce itself in a way that stands apart from nature. It blended in. And blending in is exactly what makes detection impossible. This leads to a subtle realization. The Silurian hypothesis is not weakened by the dominance of natural explanations. It is defined by it. The hypothesis exists because Earth is capable of producing extreme changes without intelligence. That capability makes intelligence unnecessary as an explanation, even if it were involved. This is uncomfortable, but important. It shows that Earth is not a reliable witness to its own past, not because it lies, but because it forgets. The planet does not care about causes. It responds to consequences. It rebalances. It moves forward. This is why Earth's history feels continuous even when it contains catastrophe. This continuity hides disruption, and disruption hides intention. So where does this leave us? It leaves us with a narrow, honest conclusion. There is no evidence that a civilization existed before humans. There is also no absolute guarantee that one did not. Earth's record cannot provide that guarantee. This does not invite belief. It invites humility. It reminds us that certainty fades with time, that deep history must be approached carefully, that our confidence must always reflect the limitations of our tools. The Silurian hypothesis survives not because it is convincing, but because it is careful. It asks a question that geology cannot fully answer. And once we accept that, the hypothesis stops being about ancient civilizations at all. It becomes a lesson about how we read the past. When the Silurian hypothesis turns its focus away from the deep past, it begins to illuminate something much closer: us. The idea that a civilization could arise and disappear without leaving a clear trace is unsettling, not because it suggests a forgotten past, but because it forces us to confront the fragility of the present. We often think of civilization as a permanent achievement. Once intelligence reaches a certain level, once technology becomes advanced enough, we assume stability follows naturally. Progress feels like a one-way path. Earth's history does not support this assumption. From a planetary perspective, civilizations are not milestones, they are phases. Temporary states that exist under specific conditions and disappear when those conditions change. Life has existed on Earth for billions of years, complex life for hundreds of millions. Intelligence, however, has existed for a very short time. Human technological civilization occupies a tiny fraction of Earth's history. This imbalance matters. It suggests that intelligence is not a guaranteed endpoint of evolution. It is a possibility that emerges under narrow circumstances, and once it emerges, it does not automatically persist. Civilizations depend on stability. They require predictable climate, reliable ecosystems, manageable resource cycles, social cooperation, knowledge transfer. All of these can be disrupted. Earth does not guarantee any of them. Climate shifts can destabilize agriculture. Resource depletion can undermine economies. Pandemics can collapse populations. Environmental feedbacks can spiral beyond control. These are not hypothetical threats. They are documented throughout human history. Every civilization that has ever existed has collapsed or transformed. None have remained stable indefinitely. Some collapsed violently, others faded quietly, but none were permanent. From Earth's perspective, this is normal. Nature does not optimize for permanence, it optimizes for balance. When a system grows beyond what its environment can support, it corrects itself, sometimes slowly, sometimes suddenly. This makes civilization inherently fragile, not because it is weak, but because it is complex. Complex systems have many points of failure. The more interconnected a civilization becomes, the more sensitive it is to disruption. Small changes can cascade. Feedback loops can amplify stress. This fragility increases with scale. A global civilization has no external buffer. There is no untouched region to recover from collapse. Everything is connected. This may explain why civilizations tend to be short-lived in geological terms. They rise quickly, consume resources rapidly, and destabilize the systems they depend on. Eventually, they reach a point where adaptation becomes difficult. This is not a moral judgment. It is a systems observation. The Silurian hypothesis invites us to view civilization not as a destiny, but as a temporary alignment of conditions. Intelligence, resources, stability, and time overlap briefly. When they stop overlapping, the phase ends. From deep time, this looks like a fluctuation, a spike in organization, a brief disturbance, then a return to baseline. If this happened once before, Earth would absorb it easily. If it happens now, Earth will absorb it again. This perspective is uncomfortable because it removes a sense of inevitability. It suggests that intelligence is not the culmination of evolution, but one of many experiments life runs. Most experiments fail. Some succeed briefly. Very few persist. This does not mean intelligence is doomed. It means survival requires something more than intelligence alone. It requires restraint, adaptation, balance. Civilizations that fail to manage their environment tend to disappear quickly. Civilizations that manage balance may last longer, but even they are not immune to change. Earth is dynamic. Conditions shift. Stability is temporary. This reframes the Silurian hypothesis as something more than a question about the past. It becomes a warning about the future. If a civilization existed before us and vanished, it did not fail because it was primitive. It failed because planetary systems are unforgiving, and if no civilization existed before us, the lesson is still the same. Earth does not preserve civilizations, it outlasts them. This does not diminish human achievement. It places it in context. We are not the first species to reshape the planet. Oxygen-producing microbes did that long before us. Plants altered the atmosphere. Life has driven mass extinctions before. We are part of a long chain of planetary experiments. What makes us different is speed. Human civilization has transformed Earth faster than most natural processes. This speed increases fragility. Systems do not have time to adjust. The Silurian hypothesis quietly asks whether speed itself is the danger. A civilization that moves slowly may leave little trace. A civilization that moves fast may leave a scar. Both may vanish. From deep time, the difference may not matter. This is why the hypothesis resonates beyond geology. It challenges the assumption that intelligence ensures survival. It reminds us that complexity increases vulnerability. And it suggests that the true test of civilization is not innovation, but endurance. Endurance does not come from domination. It comes from integration. Understanding this does not require belief in lost civilizations. It only requires honesty about the nature of systems and time. And once we see civilization as a fragile phase rather than a permanent state, the next question becomes unavoidable. If civilizations are fragile, why does intelligence arise at all? And if it arises repeatedly, why does it so often disappear? Those questions lead directly to the next section. Once we accept that civilization is a fragile phase, a deeper and more uncomfortable question appears. Why does intelligence arise at all if it so often fails to last? From an evolutionary perspective, intelligence is expensive. Large brains require energy. Complex social systems require cooperation. Technology requires knowledge transfer across generations. None of this is easy to maintain. Nature usually favors simplicity. So when intelligence appears, it is not because it is inevitable. It is because, under certain conditions, it provides an advantage. It helps organisms adapt faster than biological evolution alone would allow. But that advantage comes with risks. Intelligence allows organisms to change their environment. The more intelligent they become, the more powerful those changes are. Eventually, the environment they alter is the same environment they depend on. This creates a feedback loop. At first, intelligence stabilizes survival. Later, it destabilizes the system that supports it. This is not unique to humans. In ecology, species that overexploit resources often collapse. The same pattern applies to intelligent systems, but at larger scales. Civilizations extract energy. They concentrate matter. They simplify ecosystems. They reduce redundancy. These actions increase efficiency in the short term, but reduce resilience in the long term. Resilience matters over geological time. Earth favors systems that absorb shocks, not systems that optimize narrowly. When conditions change, systems with diversity and redundancy survive. Systems optimized for one environment fail. Intelligent civilizations tend to optimize aggressively. They build infrastructure. They centralize resources. They depend on stable conditions. This makes them vulnerable to disruption. Climate shifts, resource shortages, internal instability, external impacts. Any of these can push a civilization beyond recovery. And because civilizations are complex, recovery becomes harder as complexity increases. This may explain why intelligence is rare not in origin, but in persistence. It may arise many times. It may vanish almost as often. From a planetary perspective, this would look like brief spikes of organization separated by long periods of biological equilibrium. The Silurian hypothesis fits naturally into this pattern. It does not require a unique ancient civilization. It only requires that intelligence is not a stable end state, that it flickers rather than accumulates. This flickering would be difficult to detect. Each appearance would be short. Each disappearance would be absorbed. Each cycle would leave minimal trace. Over hundreds of millions of years, these fluctuations would blur together. Earth would look calm. This also reframes the question of rarity. Intelligence may not be rare in the universe. Long-lasting intelligence may be. Civilizations that survive long enough to leave permanent planetary signatures may be exceptional. Most may collapse before reaching that stage. This aligns with what we observe. We see no clear signs of past civilizations on Earth. We see no obvious signs of other civilizations in the cosmos. This does not necessarily mean intelligence is rare. It may mean it is brief. The Silurian hypothesis connects these two silences: Earth's silence about its past, the universe's silence about its present. Both may have the same cause, not emptiness, but impermanence. This perspective also removes a quiet bias. We often assume that intelligence, once achieved, naturally progresses toward greater stability and control. But evolution does not guarantee that direction. It only guarantees adaptation to current conditions. If conditions change faster than adaptation can respond, collapse follows. Earth changes constantly. Atmospheres evolve, continents drift, climates oscillate. Over geological time, no environment remains stable. This makes long-term civilization extraordinarily difficult. To persist, a civilization would need to adapt continuously, limit its impact, and remain flexible across vast timescales. That is an enormous challenge. It may be easier for intelligence to arise than to last. If this is true, then the absence of evidence for past civilizations is no longer surprising. It is expected. Earth is not empty of intelligence. It is quiet because intelligence does not endure easily. This does not diminish the value of intelligence. It highlights its rarity in time, not impossibility. And it brings the Silurian hypothesis to its most important function. It stops being a question about ancient history and becomes a reflection on survival. If a civilization existed before us and vanished, it was not erased maliciously. It was absorbed naturally. Earth did what it always does. It moved on. If no civilization existed before us, the lesson remains unchanged. Earth will move on again. This is not pessimism. It is realism shaped by deep time. Understanding this does not mean abandoning progress. It means redefining success, not as dominance but as endurance, not as expansion but as balance. From Earth's perspective, intelligence that lasts is intelligence that learns restraint, and that may be the hardest lesson of all. When scientists search for intelligence beyond Earth, they often start with a simple assumption. If intelligence exists, it will make itself visible. It will transmit signals. It will alter its planet. It will leave marks that stand out from nature. This assumption feels reasonable because it is based on us. Human civilization is noisy. We emit radio waves. We illuminate the night side of our planet. We alter atmospheric chemistry. We leave a growing technological footprint that could, in principle, be detected from space. So when scientists look outward, they search for similar signs: radio signals, artificial light, industrial pollution in atmospheres. But the Silurian hypothesis quietly challenges this entire strategy. If Earth itself cannot reliably preserve evidence of past intelligence, then expecting distant planets to advertise intelligence permanently may be unrealistic. Earth becomes a warning. It shows how easily intelligence can arise, alter its environment briefly, and then vanish without leaving a clear signature. If this can happen here, it can happen elsewhere. This changes how we interpret silence. When we scan the sky and hear nothing, we often conclude that intelligence is rare, that we are alone, that life seldom advances beyond biology. But silence does not necessarily mean absence. It may mean impermanence. A civilization could exist for thousands of years, develop technology, explore its environment, and even alter its planet slightly. Then it could collapse. Over time, its signals fade, its atmospheric effects stabilize, its structures decay. By the time another civilization looks its way, nothing obvious remains. From a distance, the planet looks natural again. This means that our search strategies may be biased towards civilizations that are not just intelligent, but also loud, long-lasting, and currently active. These may be the rarest kind. The Silurian hypothesis suggests that intelligence may flicker across cosmic history rather than accumulate steadily. Planets may host multiple intelligent phases separated by long periods of quiet. From the outside, these phases are almost impossible to detect, unless we happen to look at exactly the right time. This reframes the famous question, where is everybody? Perhaps they were here, perhaps they are gone, perhaps they were never meant to last long enough to be seen. This does not make the universe empty, it makes it patient. The hypothesis also challenges how we think about technological signatures. We often search for markers of industrial activity. But Earth shows that industrial activity is not the only path intelligence can take. It is just one path, and a particularly destructive one. A civilization that prioritizes sustainability, balance, or biological integration may produce very few detectable signals. Its energy use may be modest. Its infrastructure may be biodegradable. Its waste may be minimal. Such a civilization could be intelligent and advanced, yet nearly invisible from space. This does not make it less advanced. It makes it harder to detect. Earth teaches us that the civilizations most likely to survive longer may also be the ones least likely to announce themselves across the cosmos. This creates a paradox. The civilizations we are most likely to find may be the ones most likely to collapse. The civilizations most likely to endure may be the ones we never notice. The Silurian hypothesis does not solve this paradox. It exposes it. It reminds us that our search for intelligence is shaped by our own behavior. We look for ourselves because we know ourselves, but the universe may not mirror our path. This is not a failure of imagination. It is a limitation of perspective. Earth's history shows that intelligence does not guarantee dominance. It does not guarantee permanence. It does not guarantee visibility. It only guarantees possibility. This should make us cautious when interpreting cosmic silence. Silence is not evidence of emptiness. It is evidence of limits. Limits in time, limits in detection, limits in persistence. The universe may be filled with stories that ended before we arrived. And just as Earth forgets its own past, the cosmos may forget most civilizations that ever existed. This does not mean we should stop searching. It means we should search more humbly. We should look for subtle patterns rather than obvious signals. We should study planetary atmospheres over time. We should examine geological histories of other worlds, not just their present state. We should accept that intelligence may not leave permanent scars. Earth has already taught us that lesson. The Silurian hypothesis turns Earth into a case study, not of lost civilizations, but of lost certainty. It shows that our planet cannot guarantee a complete record of its own past, and if Earth cannot do that, distant planets certainly cannot. This does not make science weaker, it makes it wiser. By recognizing the limits of detection, we avoid false conclusions. We stop equating silence with emptiness. We stop assuming that intelligence must be visible to matter. Instead, we learn to treat absence cautiously, and that leads to the next realization. If silence does not mean absence in the cosmos, then the universe may be far more active than it appears. Understanding that requires us to rethink what silence really means. When scientists search for intelligence beyond Earth, they often start with a simple assumption. If intelligence exists, it will make itself visible. It will transmit signals. It will alter its planet. It will leave marks that stand out from nature. This assumption feels reasonable because it is based on us. Human civilization is noisy. We emit radio waves. We illuminate the night side of our planet. We alter atmospheric chemistry. We leave a growing technological footprint that could, in principle, be detected from space. So when scientists look outward, they search for similar signs: radio signals, artificial light, industrial pollution in atmospheres. But the Silurian hypothesis quietly challenges this entire strategy. If Earth itself cannot reliably preserve evidence of past intelligence, then expecting distant planets to advertise intelligence permanently may be unrealistic. Earth becomes a warning. It shows how easily intelligence can arise, alter its environment briefly, and then vanish, without leaving a clear signature. If this can happen here, it can happen elsewhere. This changes how we interpret silence. When we scan the sky and hear nothing, we often conclude that intelligence is rare, that we are alone, that life seldom advances beyond biology. But silence does not necessarily mean absence. It may mean impermanence. A civilization could exist for thousands of years, develop technology, explore its environment, and even alter its planet slightly. Then it could collapse. Over time, its signals fade, its atmospheric effects stabilize, its structures decay. By the time another civilization looks its way, nothing obvious remains. From a distance, the planet looks natural again. This means that our search strategies may be biased towards civilizations that are not just intelligent, but also loud, long-lasting, and currently active. These may be the rarest kind. The Silurian hypothesis suggests that intelligence may flicker across cosmic history rather than accumulate steadily. Planets may host multiple intelligent phases separated by long periods of quiet. From the outside, these phases are almost impossible to detect unless we happen to look at exactly the right time. This reframes the famous question, where is everybody? Perhaps they were here. Perhaps they are gone. Perhaps they were never meant to last long enough to be seen. This does not make the universe empty. It makes it patient. The hypothesis also challenges how we think about technological signatures. We often search for markers of industrial activity. But Earth shows that industrial activity is not the only path intelligence can take. It is just one path, and a particularly destructive one. A civilization that prioritizes sustainability, balance, or biological integration may produce very few detectable signals. Its energy use may be modest. Its infrastructure may be biodegradable. Its waste may be minimal. Such a civilization could be intelligent and advanced, yet nearly invisible from space. This does not make it less advanced, it makes it harder to detect. Earth teaches us that the civilizations most likely to survive longer may also be the ones least likely to announce themselves across the cosmos. This creates a paradox. The civilizations we are most likely to find may be the ones most likely to collapse. The civilizations most likely to endure may be the ones we never notice. The Silurian hypothesis does not solve this paradox, it exposes it. It reminds us that our search for intelligence is shaped by our own behavior. We look for ourselves because we know ourselves. But the universe may not mirror our path. This is not a failure of imagination, it is a limitation of perspective. Earth's history shows that intelligence does not guarantee dominance. It does not guarantee permanence. It does not guarantee visibility. It only guarantees possibility. This should make us cautious when interpreting cosmic silence. Silence is not evidence of emptiness. It is evidence of limits. Limits in time. Limits in detection. Limits in persistence. The universe may be filled with stories that ended before we arrived. And just as Earth forgets its own past, the cosmos may forget most civilizations that ever existed. This does not mean we should stop searching. It means we should search more humbly. We should look for subtle patterns rather than obvious signals. We should study planetary atmospheres over time. We should examine geological histories of other worlds, not just their present state. We should accept that intelligence may not leave permanent scars. Earth has already taught us that lesson. The Silurian hypothesis turns Earth into a case study, not of lost civilizations but of lost certainty. It shows that our planet cannot guarantee a complete record of its own past, and if Earth cannot do that, distant planets certainly cannot. This does not make science weaker, it makes it wiser. By recognizing the limits of detection, we avoid false conclusions. We stop equating silence with emptiness. We stop assuming that intelligence must be visible to matter. Instead, we learn to treat absence cautiously. And that leads to the next realization. If silence does not mean absence in the cosmos, then the universe may be far more active than it appears. Understanding that requires us to rethink what silence really means. Silence is one of the most misleading signals in science. When we do not see something, the instinctive conclusion is that it does not exist. But this instinct only works when we are certain that our tools are capable of detecting what we are looking for. The Silurian hypothesis reminds us that this certainty may be misplaced. Earth itself is silent about most of its own history. Entire eras have passed with little surviving evidence. Species have risen and vanished without leaving clear traces. Even major transitions are often inferred indirectly, reconstructed from incomplete data. Earth's silence does not mean nothing happened, it means the record is incomplete. This insight changes how we interpret silence in the universe. When we scan the cosmos and detect no clear signs of intelligence, we often assume intelligence is rare or non-existent. But Earth suggests another possibility. Intelligence may arise often, but briefly. Civilizations may appear, alter their environment modestly, and then disappear. Over time, their signals fade. Their planets return to equilibrium. From a distance, nothing obvious remains. The silence we observe may not be emptiness. It may be erasure. This is not speculation pulled from imagination. It is a conclusion grounded in how Earth behaves. Our own planet actively removes evidence of short-lived phenomena. Over geological time, it smooths out disruptions and hides their causes. The universe may do the same. Stars evolve, planets change, atmospheres stabilize, radiation erases signals, structures decay. Over cosmic time, information is lost. This means that the universe is not just vast in space, it is vast in time, and time hides far more than distance. We tend to imagine civilizations as permanent beacons. Once they arise, we assume they broadcast indefinitely. But Earth teaches us that civilizations are fragile and temporary. They do not accumulate forever. They reset. If this is true, then the universe may have hosted many civilizations that never overlapped in time. Each one existed alone, unaware of the others, separated not by space, but by eras. From our perspective, this looks like loneliness. From a cosmic perspective, it looks like staggered activity. This idea also reframes the meaning of detection. We often look for current activity, but the majority of intelligent life that ever existed may no longer exist. Their planets may look quiet now, but they were not always so. This means our searches are biased toward a narrow slice of cosmic history. We are looking for civilizations that are technologically active, planetary scale, long-lasting, and currently alive. That is a very restrictive filter. Earth itself would only meet those criteria for a brief moment. For most of its history, Earth would appear uninhabited or biologically simple from afar. If an alien civilization had scanned Earth 100 million years ago, they would see no cities, no signals, no technology. Earth would appear quiet and natural. Yet intelligence was coming. Silence would have been misleading. The Silurian hypothesis extends this lesson outward. It suggests that many planets we observe today may be between civilizations, or past civilizations, or future ones. The absence of signals tells us very little about their full history. This does not make detection impossible, it makes it probabilistic. We may need to search not just for activity, but for scars, not just for signals, but for subtle anomalies, not just for presence, but for change. Earth's geological record shows that the most durable evidence of past events is not structure, but transformation. Atmospheric composition, isotope ratios, long-term climate shifts. Even these fade, but they last longer than signals. This is why planetary science is becoming increasingly important in the search for intelligence. Studying exoplanet atmospheres over time may reveal histories rather than snapshots. The Silurian hypothesis encourages this shift. It tells us to stop assuming intelligence must announce itself loudly and continuously. It tells us to accept that intelligence may be quiet, brief, and easily erased. This does not make the universe empty, it makes it subtle, and subtlety requires patience. Science advances not by demanding answers, but by refining questions. The Silurian hypothesis refines one of the biggest questions we ask. Instead of asking, where are the others? It asks, how long do others last? Instead of asking, why don't we see them? It asks, what would it even look like if they were gone? These questions are harder but more honest. They acknowledge the role of time as a filter. They recognize that the universe does not preserve activity equally. They accept that silence can mean many things. Earth's own history is proof of this. The The planet is ancient. Life has come and gone. Most stories are lost, yet life continues. Intelligence may be one of those stories. Not unique, not permanent, but meaningful while it lasts. The Silurian hypothesis does not ask us to believe that we are not the first. It asks us to accept that we cannot be certain. And that uncertainty matters, because it shapes how we search, how we interpret silence, and how we understand our own place in time. Once we accept that silence does not equal absence, the hypothesis reaches its deepest implication. It is no longer about the past. It is about how we define existence in a universe that forgets. The Silurian hypothesis survives only because it respects skepticism. This is important to say clearly. Science does not advance by accepting ideas because they are interesting or unsettling. It advances by questioning them relentlessly. Any idea that cannot survive skepticism does not belong in science. The Silurian hypothesis is not protected from doubt. It depends on it. In fact, the strongest arguments against the hypothesis come from the same scientific principles that make it worth discussing at all. The first and most important argument is simple. Earth's geological record, while incomplete, is not meaningless. It preserves long-term trends with remarkable reliability. Major changes in atmosphere, climate, and biology leave detectable signatures. We can identify oxygenation events that happened billions of years ago. We can detect ice ages hundreds of millions of years old. We can trace mass extinctions and recoveries with surprising detail. This tells us something critical. Earth may erase details, but it preserves large, sustained changes. If a civilization had existed at a global scale and altered the planet for a long time, it would almost certainly leave a recognizable imprint. This is the strongest constraint on the hypothesis. Human civilization, if it continues at its current scale for millions of years, will leave a clear geological signal. Carbon isotopes, synthetic compounds, altered sedimentation patterns, and long-term ecological disruption would be difficult to erase completely. So far, no such unmistakable signal exists in Earth's deep past. That matters. It does not disprove the hypothesis, but it limits it sharply. Any past civilization would have to be either short-lived, limited in scale, or fundamentally different in how it interacted with the planet. The second argument concerns energy use. Advanced civilizations tend to consume energy at increasing rates. Energy use leaves traces. Heat alters climate. Waste accumulates. Resource extraction reshapes landscapes. Earth's past shows no clear evidence of sustained high-energy activity comparable to industrial civilization. Again, this places limits. It suggests that if intelligence arose before humans, it did not reach a stage of high-energy planetary transformation. Or if it did not last long. The third argument involves biological evolution. Civilizations do not exist in isolation. They interact with ecosystems. They influence species distributions. They change selective pressures. A long-lived civilization might leave indirect evolutionary signatures. Certain species might thrive unnaturally. Others might disappear prematurely. Domestication could alter lineages. So far, no evolutionary patterns require the presence of past intelligence to explain them. Evolutionary history makes sense without invoking civilization. This is important. The Silurian hypothesis does not override existing explanations. It must fit within them. If an idea requires rewriting biology, geology, and climate science, it fails. The hypothesis survives only because it does not do that. It operates in the margins, not at the center. The fourth argument is methodological. Science avoids unfalsifiable ideas. If every lack of evidence can be explained by erasure, then the hypothesis risks becoming immune to testing. That is dangerous. An idea that cannot, even in principle, be challenged is not scientific. This is why the Silurian hypothesis is framed carefully. It does not say, there was a civilization and Earth erased all evidence. It says, given Earth's erasure processes, Certain kinds of civilizations could exist without leaving clear evidence. That difference matters. The hypothesis remains testable because it makes conditional predictions. It tells us what would count as strong evidence against it. And that brings us to an important point. Skepticism does not weaken the hypothesis. It defines its boundaries. Without skepticism, the idea would drift into speculation. With skepticism, it remains an intellectual tool rather than a belief system. This is why most scientists treat the Silurian hypothesis as a thought experiment. It sharpens thinking about deep time. It exposes assumptions about preservation. It highlights limits of certainty. It does not demand acceptance. And this is exactly how science should behave. The hypothesis also teaches restraint in storytelling. Humans love narratives. We like beginnings, climaxes, and hidden histories. But science resists storytelling when evidence is thin. It favours probabilities, not myths. The Silurian hypothesis survives because it does not tell a story. It asks a question, and it allows the answer to remain incomplete. This humility is essential. Without it, the idea would quickly collapse under its own weight. The strongest argument against the hypothesis is not that it is wrong. It is that there is no need for it to explain what we observe. Earth's history works without it. Biology works without it. Climate science works without it. That is a powerful point. The hypothesis exists not because evidence demands it, but because certainty does not. It fills a gap in our confidence, not a gap in data. This distinction keeps it grounded, and it prepares us for the next section. If skepticism is essential, then the next question is unavoidable. What kind of evidence would actually challenge or support the hypothesis in a meaningful way? That is where we go next. If skepticism defines the limits of the Silurian hypothesis, then evidence defines its credibility. Not any evidence, not vague anomalies, but specific kinds of signals that cannot be explained easily by known natural processes. This is where the hypothesis becomes precise. It does not ask us to imagine what might be possible. It asks what would actually change scientific confidence. So what kind of evidence would truly matter? First, it would have to be global. Local anomalies mean very little. Earth produces strange local chemistry, odd fossils, and unusual geological formations all the time. These are expected. They do not imply intelligence. A meaningful signal would have to appear across continents and oceans, synchronized in time, and clearly outside normal variation. Planetary scale change is the minimum requirement. Second, the signal would have to be persistent. Short-lived events are common. Volcanic eruptions, impacts, and climate swings can be sudden and dramatic, but they fade. A civilization-level signature would likely require sustained activity over thousands or millions of years. That persistence would leave a layered signal, not a spike. For example, a long-term alteration of atmospheric chemistry that cannot be explained by volcanism or biological processes alone would be significant. A sustained imbalance in multiple chemical cycles at once would be harder to dismiss. But such a signal has not been found. Third, the signal would need to be internally inconsistent with nature. Nature is powerful, but it follows patterns. Volcanism affects carbon and sulfur in predictable ways. Biological activity alters oxygen and nitrogen within known limits. Impacts leave distinctive physical traces. A signal that violates these patterns would raise questions. For instance, the widespread presence of complex synthetic molecules that do not arise naturally and persist across geological layers would be difficult to explain, or a combination of chemical signatures that point to controlled energy use rather than random release. Again, no such signal has been identified. This matters. The absence of such evidence does not make the hypothesis false, but it keeps it firmly in the realm of possibility rather than probability. Another type of evidence would involve evolutionary disruption. If a civilization domesticated species or reshaped ecosystems intentionally, that might leave unusual evolutionary patterns. Sudden global appearance of species with traits optimized for human-like environments, for example. But evolution already produces strange jumps and convergences. Domestication signatures would be subtle and easy to misinterpret. So far, evolutionary history does not require intelligence to explain it. There is also the question of long-lived materials. Some human-made materials persist longer than natural ones. Certain radioactive isotopes, for example, have half-lives long enough to be detectable over millions of years. If large quantities of such materials were found in deep time layers without natural explanation, that would be extraordinary, but they are not there. This absence places another strong constraint. Any past civilization would have had to avoid producing long-lived waste at scale. That narrows possibilities further. Taken together, these requirements form a tight filter. For a civilization to be detectable in deep time, it would need to be global long-lasting high energy, chemically distinctive, and evolutionarily disruptive. Such a civilization would be very hard to hide. Earth shows no evidence of one. This is why most scientists conclude that if a civilization existed before humans, it was likely very different from ours. Small, brief, low impact, or so ancient that all signals have been completely recycled. The hypothesis survives only within these constraints, and this is exactly how science should work. It does not chase possibility without boundaries, it defines boundaries first. The Silurian hypothesis does not grow stronger with time, it remains narrow and cautious. New data does not support it, but neither does it completely eliminate it. This balance is important. It prevents the idea from becoming belief. It keeps it as a tool for thinking, not a claim to defend. And that is its true value. The hypothesis teaches us how fragile evidence is across deep time. It reminds us that certainty fades quickly as we move backward. It forces us to confront how much we assume about the past based on limited records. It also prepares us for humility. We are used to thinking of ourselves as the first, the only, the peak. But deep time does not reward such confidence. It dissolves it. Whether or not a past civilization existed is almost secondary. The important lesson is this: Earth does not promise memory, time does not preserve meaning, and intelligence is not guaranteed permanence. The Silurian hypothesis ends not with an answer, but with a refined understanding of limits. And that brings us to the final stage of the discussion. If the hypothesis is less about proving the past, then what does it ultimately teach us? The Silurian hypothesis does something subtle but important. It does not try to rewrite Earth's history. It rewrites how confident we feel about it. For most of human history, we believed the world was young. Time felt short. History felt manageable. Then science expanded the timeline. Millions of years became normal, then billions. With each expansion, something changed. Human certainty shrank. Deep time forces humility. When we place human civilization against Earth's full timeline, the contrast is overwhelming. Everything we have built exists within a thin slice of time so narrow that it nearly disappears. From this perspective, confidence begins to look fragile. We often speak about being the first or the only because our records show no others. But deep time reminds us that records are temporary. An absence of memory is not proof of uniqueness. The Silurian hypothesis presses directly on this point. It asks us to separate evidence from confidence. We have evidence of human civilization. We do not have evidence of earlier ones. But what we do not have is certainty that Earth could preserve such evidence indefinitely. That difference matters. Human confidence tends to grow in the gaps left by incomplete knowledge. We fill silence with conclusions. We treat what we see as all that exists. Deep time challenges that instinct. Earth is not obligated to remember. It does not archive its own history faithfully. It compresses, erases, and rearranges it. Once we accept this, humility follows naturally. We stop asking, why don't we see them? We start asking, what would we even expect to see? This shift is powerful. It does not make humans less important. It makes our moment more fragile. The Silurian hypothesis reminds us that intelligence does not automatically leave a lasting mark. Even dramatic events can fade. Even global disruptions can become indistinguishable from background noise. This challenges a deep human belief. We like to believe that intelligence matters cosmically, that once intelligence appears, it becomes permanent, that the universe changes forever. Earth does not support this belief. Earth supports continuity, not memory. Life continues. Systems rebalance. Stories disappear. From this perspective, human civilization is not a culmination. It is an experiment. One of many Earth has run. This is not pessimistic. It is clarifying. It removes the illusion of destiny and replaces it with responsibility. If intelligence is not guaranteed to last, then its survival becomes a choice, not a fate. Deep time also changes how we view progress. We often measure progress in growth, more energy, more control, more complexity. But deep time does not reward growth. It rewards stability. Systems that grow too fast destabilize. Systems that remain adaptable survive. The Silurian hypothesis quietly suggests that confidence in permanent progress may be misplaced. If a civilization existed before us and vanished, it was not because it failed to become advanced enough. It was because advancement alone does not guarantee endurance. If no civilization existed before us, the lesson remains. Nothing about intelligence exempts it from planetary limits. Deep time dissolves ego. It reminds us that Earth existed long before us and will exist long after us. That our structures are temporary, that our signals fade. This does not make our achievements meaningless, it makes them rare. Meaning does not come from permanence, it comes from awareness. The Silurian hypothesis ultimately teaches us how to hold knowledge gently, to accept that science reveals patterns, not certainties, to recognize that confidence should always match the strength of evidence. In deep time, evidence thins quickly, certainty becomes expensive, humility becomes necessary. This is why the hypothesis resonates even without proof. It aligns with what deep time consistently teaches us. That history is fragile, that memory decays, that intelligence is brief. And once we accept this, the final question emerges naturally. If the hypothesis does not give us answers, why does it matter at all? That question leads to the final section. The Silurian hypothesis does not give us a clear conclusion, and that is precisely why it matters. In science, not every valuable idea leads to an answer. Some ideas exist to reshape how questions are asked. Some exist to reveal assumptions we did not realize we were making. This hypothesis does both. At first glance, it seems like a question about the past. Were there civilizations before us? Did intelligence arise and vanish long before humans appeared? But beneath that surface, the question is deeper. It is about how we understand evidence. It is about how we interpret silence. It is about how confident we should be in our conclusions when time stretches beyond comprehension. The Silurian hypothesis matters because it exposes a blind spot. We are excellent at studying what survives. We are poor at recognizing what disappears completely. Science is built on observation. But observation depends on preservation. If something leaves no trace, it sits outside our data. Not because it did not exist, but because it did not endure. This creates a natural bias. We assume that what we see is representative of what happened. But deep time shows us that this assumption is risky. Earth filters history aggressively. Only certain kinds of information pass through. The hypothesis reminds us to ask whether absence of evidence is truly evidence of absence. This question applies far beyond ancient civilizations. It applies to climate history, to evolutionary transitions, to the search for life beyond Earth. It teaches caution in every domain where time erases detail. The question also matters because it reframes humanity's position. If we assume we are the first, we may also assume we are exceptional in ways that matter morally or cosmically. We may assume progress is inevitable. That intelligence naturally leads to permanence. The Silurian hypothesis removes that comfort. It places us in a long sequence of possibilities rather than at the beginning of a story. It suggests that intelligence may not be a singular event, but a recurring one. That civilizations may rise and fall without leaving names or monuments. This does not make humanity smaller. It makes our moment sharper. If we are not guaranteed permanence, then what we do now matters more, not less. Our choices shape whether our civilization becomes a brief fluctuation or something that endures. The hypothesis also matters because it changes how we think about legacy. Humans often seek permanence. We build monuments. We record histories. We imagine future observers looking back at us. Deep time challenges this desire. Most legacies fade. Most records disappear. Most stories are lost. What survives is not intention, but consequence. Earth remembers chemistry better than culture. It remembers mass better than meaning. Understanding this does not lead to despair. It leads to clarity. It shifts the goal from being remembered to being sustainable. If no one remembers us in 100 million years, what matters is whether life continues in a healthy way, whether ecosystems persist, whether the planet remains habitable. The Silurian hypothesis subtly encourages this perspective. It asks us to measure success not by how loudly we announce ourselves, but by how gently we pass through time. There is also a lesson in restraint. The hypothesis survives because it does not claim more than the evidence allows. It does not insist on answers. It accepts uncertainty. This is rare in a world that prefers certainty. By allowing the question to remain open, the hypothesis demonstrates scientific maturity. It shows that not knowing is sometimes the most honest position. We often think science advances by closing questions, but it also advances by opening better ones. The Silurian hypothesis opens a better question. Not, were there civilizations before us? But, how reliable is Earth's memory? That question has real consequences. It affects how we interpret the fossil record. It affects how we search for life on other planets. It affects how we understand our own vulnerability. It encourages humility in every direction. In the end, the hypothesis does not ask us to believe anything extraordinary. It asks us to accept something ordinary. Time erases. Earth forgets. Intelligence does not guarantee permanence. Whether or not we were the first becomes less important than how briefly intelligence touches a planet before conditions change. The question matters because it shifts our focus from uniqueness to responsibility, from certainty to care, from dominance to balance, and that prepares us for the final part. Because once we understand what the hypothesis teaches us, there is only one thing left to do: to step back and see ourselves not as the center of Earth's story, but as a moment within it. At the end of this question, something becomes clear. Earth does not care who came first. It does not care who was intelligent. It does not care who built tools or understood nature. It does not care who asked questions or searched for meaning. Earth responds only to consequences. This is the hardest idea to accept. We often imagine history as a sequence of achievements, each building on the last, but Earth does not see history that way. From the planet's perspective, time is not a story, it is a process. Things appear, they interact, they disappear. Life has followed this rhythm for billions of years. Species rise and dominate ecosystems, then conditions change and they vanish. Forests spread across continents, then retreat. Oceans expand and shrink. Ice comes and goes. None of this is remembered intentionally, it simply happens. The Silurian hypothesis fits naturally into this rhythm. It does not require a dramatic lost age. It does not require hidden ruins or forgotten empires. It only requires the acceptance that intelligence, like all complex phenomena, may be temporary. If a civilization existed before us, it did not fail because it was weak or foolish. It failed because Earth changes, and Earth always changes. From deep time, civilizations are indistinguishable from other brief reorganizations of matter. They concentrate energy for a moment, then disperse. They leave. Disturbances that fade, they pass through. This perspective removes drama from the question. There is no tragedy in forgetting. There is no injustice in erasure. Earth is not an archivist. It is a system. Systems optimize for balance, not memory. Once we understand this, the need for certainty fades. The question of whether we are the first civilization becomes less important than how civilizations behave while they exist. Earth has hosted oxygen catastrophes that wiped out most life. It has endured asteroid impacts that reshaped evolution. It has survived volcanic winters and runaway greenhouse states. Compared to these forces, civilizations are small, powerful locally, fragile globally, brief in time. The Silurian hypothesis does not elevate past civilizations. It humbles all of them, including ours. It tells us that intelligence is not a crown placed on Earth. It is a flicker that appears under certain conditions, and flickers do not last forever. This realization does not strip meaning from intelligence. It changes where meaning comes from. Meaning does not come from being remembered forever. It comes from what happens while something exists. Earth does not remember civilizations. Civilizations remember Earth, and that memory shapes their choices. If a civilization existed before us, it is gone. Earth absorbed it completely. Life continued. New species emerged. Conditions changed. If no civilization existed before us, the process remains the same. Earth will absorb us too, not with malice, not with intent, with time. This is not a warning, it is a description. Understanding this allows us to step out of the need to be special and into the need to be careful. Because if Earth does not care who came first, then being first gives us no protection. Only behavior matters. In the end, the Silurian hypothesis does not answer the question it raises, and that is its strength. It leaves us with a lesson instead of a conclusion. The lesson is not that ancient civilizations existed. The lesson is not that they did not. The lesson is that deep time erases certainty. Earth's past is not a complete story. It is a collection of survivors. What remains is not what mattered most, but what endured longest. This means our understanding of history is always incomplete, and that incompleteness should shape how we think about ourselves. We live in a moment when intelligence is changing the planet rapidly. We measure progress in speed, scale, and control, but deep time measures something else. It measures endurance. From Earth's perspective, the most successful systems are not the loudest or the fastest. They are the ones that remain stable across change. The Silurian hypothesis quietly asks whether intelligence is capable of that kind of stability. Not brilliance, not innovation, but restraint. It forces us to confront an uncomfortable idea. If intelligence cannot learn to coexist with planetary systems, it may always remain temporary, appearing, altering, vanishing, over and over again. Earth would not notice the difference. Life would continue. This reframes the idea of legacy. A civilization's true legacy is not what it leaves behind in rock. It is what it allows to continue after it is gone. If Earth remains habitable, that is success. If life continues to evolve, that is success. Whether anyone remembers us does not matter to the planet. The Silurian hypothesis strips away the fantasy of permanence and replaces it with responsibility. It tells us that intelligence is not a destiny. It is a test, not a test of knowledge, a test of balance. And balance is difficult. Earth does not reward ambition alone. It rewards adaptation. It rewards systems that fit within limits rather than trying to escape them. This is the quiet lesson hidden inside the hypothesis, not about the past, about the future. Whether or not we were the first civilization, we may still be early in understanding what it takes to last. The universe does not owe us continuity. Earth does not promise memory. All we have is the present moment and the choices we make within it. The Silurian hypothesis ends where it began, with humility, with the acceptance that time is vast, memory is fragile, and intelligence is brief. And with one final realization, Earth has hosted countless forms of life. It may host countless forms of intelligence, but it will never pause to remember any of them. It will simply continue.